What kind of site would you rather create? One that relies on clearing, blasting, walls, pipes, and expensive infrastructure to manage constraints? Or one that works with the land, using its natural shape and features to manage water, create shade, support ecology, and provide green space people can enjoy? At MDI, we help developers, First Nations, rural, and remote communities understand how their land functions so development can fit the landscape, not fight it. This is the kind of site we are often asked to assess. Forested, complex, and potentially expensive to survey. There may be a lot of unknowns, but there's a lot of information available if you know how to understand it. Using available information including LiDAR, we can quickly build a practical first picture of how a site functions. LiDAR uses pulses of laser light to measure the land surface from the air. The pulses bounce back from trees, buildings, and the ground, creating a detailed digital model of the site. With publicly available LiDAR data, we can begin to understand large or difficult sites before full on-site survey and assessments are completed. From the LiDAR data, we can determine tree height, which helps us understand where the forest is dense, where there are disturbances, and where vegetation patterns may influence future planning. By filtering the data, we can reveal the Earth's surface beneath the vegetation. Ridgelines, valleys, benches, depressions, and subtle landforms begin to appear. These features shape drainage, access, grading, and development potential. Slope is one of the first filters. Steep terrain can increase construction costs, create erosion risk, and limit safe access and development. We identify areas that may exceed practical thresholds, creating an early picture of where development may be more difficult. Next, we look at how water moves and collects on the site. Every development is located in a watershed. Before design begins, we need to understand where water comes from, where it goes, and what the land is already telling us. Wetness modeling and surface flow analysis can show where water concentrates, where it may linger, and where potential watercourses or wetlands exist, even when they are not obvious from aerial imagery alone. Potential riparian protection areas, such as SPIAs, can then be mapped around watercourses and wetlands based on applicable guidelines and further environmental review. Combined with steep slope areas, we begin to see what parts of the site are asking to be protected or avoided. What remains is where development has the best chance of fitting well: flatter, drier, more accessible land that is clear of the features that define the site's ecological function. The land already has value: structure, trees, habitat, and identity. Instead of relying only on engineered systems, the plan can work with the existing landform, natural drainage patterns, vegetation, and existing site disturbances. This becomes the foundation for a framework plan, not a final design, but an informed starting point where major decisions are made. When we understand the land before design begins, we can reduce unnecessary infrastructure, protect intrinsic site value, and create places that support development, people, and local ecology. Good planning starts with that choice.